We have Amy Schmidt from the University of Nebraska, and then Andy Schulting from Nutrient Advisors of West Point, joining us here on the call today. So I'd like to take a moment to welcome them. We're going to have a discussion about nutrient management plans, and then valuing nutrient as an input in our row crop enterprises. So I think each of you have some slides and so forth that you want to share. So Amy, I'm going to let you lead us off to talk about yourself and what you do at the university, and share what you have for us today.
All right, thank you, Will. I'm going to go ahead and share my presentation, make sure it's showing up for everybody. Are you seeing the presenter view there?
Yes.
Okay, very good. Well, thanks a lot. I'm happy to be here, and appreciate that I was asked to speak alongside Andy Schulting. I was asked to talk a little bit about testing and valuing swine deep pit manure, and so so I'm going to try to cover that fairly briefly so that we have time for questions at the end. So I'm going to jump right in here, and the first thing I would say is that when we think about value, we all have different perceptions of how valuable something or someone or a concept is. And we really base that on our own personal, the usefulness of that thing, or the importance of it to us. And so manures, you know, it's no different. This idea that one man's trash is another man's treasure, it comes down to our individual perceptions of importance or usefulness. And so what I would challenge you to think about is, when does manure have value? Of course, you know, I might have a different view of its value because I value the nutrients but not the odor. And that could be different from another person's. But if we think about it from purely a nutrient aspect, manure has value when the nutrients that are in it can be recycled and used in crop production on land that needs the nutrients. So if the land doesn't need the nutrients, we can put manure on it, but we're really not getting the value from the nutrients that are being applied, right? And so that's kind of an immediate value. We apply a certain amount of manure or fertilizer. It has a certain amount of nutrients, which have a certain monetary value. And in the end, we get a yield, and overall the value is, what did we put in versus what did we get out? And we see that fairly quickly. We see that from the beginning and to the end of a cropping season. But there are other longer term benefits as well. And so I would add to the value is the idea of what gives manure value is that not only can it be recycled and used for crops, but we recognize either those immediate or short-term benefits, or we recognize and appreciate the potential long-term benefits of using manure in a cropping system. So if we start in thinking about like the monetary value of manure, think about the operating costs associated with a crop production system in this region of the country. There's a number of expenses that go into that, chemicals, the seed, the repairs to equipment, and things like that. But one of the single largest inputs is the cost of fertilizer. And that doesn't matter if you're a crop farmer without livestock and you're purchasing inorganic fertilizer or manure, and maybe having to pay for those products to be applied to your field, or if you're a crop farmer who owns livestock and you're able to utilize some of the manure from your livestock on your farm and offset the cost of having to purchase inorganic fertilizer. So in both cases, there's still that amount of operating cost going in. It's whether you have to go out and get it elsewhere, or if you have it and prevent yourself from going out and having to spend that money on inorganic fertilizer. What we don't necessarily think about in terms of farm value and in terms of manure value is how it impacts the soil and the quality of the cropland and the value of the cropland, because it's really hard to measure that. It's hard to assign a monetary value to it. And it doesn't happen quickly. It's something that takes a lot more time. And so we tend not to think as much about that long-term impact. But if you think about your land, specifically the soil within a field, is your cropland resilient? We hear that term resilient or resilience a lot lately. And a lot of times we hear that in relation to climate change. Is your operation resilient to changing weather conditions? I would also say, is your system healthy, and is it delivering the greatest possible value to your cropping system? So if, you know, soils based on their quality, their structure, their physical, chemical, biological properties, they recycle nutrients differently. They hold water differently. Infiltration is different. Is topsoil staying put in your soil, in your field, or is it getting carried away by runoff and erosion? Again, probably not something you see and really see a measurable change over time, over a short time, but over a long time that can make a big difference. And so I would argue that manure has a role in improving the resilience of cropland. So what does it mean to be resilient? Means that the land is able to respond to external changes and pressures without a lot of disruption in the system. So that could be, flooding, erosion, runoff, drought, a lot of the things that we've seen in the last few years here in Nebraska, and a lot of other people have seen in other parts of the country as well. So it's not easy to assign a value to those, but there's certainly value there. Several characteristics of soil can impact the value that's of a particular parcel of land. So, some of the things that manure can impact, the potential moisture holding capacity of soil, which also can impact the potential for erosion and runoff, the permeability of soil, the nutrient cycling efficiency in the soil. And so a lot of these characteristics in the long term are going to be important to the resilience of that cropping system and maybe the value of the land itself down the road. But we have to start kind of at the simplest point, which is knowing, what's in manure, what makes it valuable as a fertilizer. And since sampling and understanding what's in manure was one of the things I was asked to talk about, I'm going to cover that fairly briefly. I don't want to get into detail of how to actually sample and do all that, but just some basic recommendations. So for instance, if you're sampling from a deep pit, it doesn't do any good to take a sample out of there from the surface of the pit, send it for analysis, and then agitate and pump the manure and expect that what your lab result showed is what you're getting in that. So, if it's going to be agitated and stored, which it should be before it's applied, then the sample needs to be taken when it's well mixed as well. You should collect multiple samples over time as you're pumping it out. You should collect from year to year. You should see, if an operation isn't making changes in types of feed or water use, those sorts of things, you should see that be fairly consistent over time, those results that you get back on the manure analysis. Once you collect a sample, don't leave it in the bed of a truck or the cab of your truck for a day where it gets heated up and hopefully doesn't pop open, but that can happen as well. So keep the samples cool, get them submitted to the lab quickly, and most labs have what they would call a standard or a basic manure analysis, and that will get you pretty much all of the information that you would need for calculating a nutrient value of that manure. So when you get your lab result back, it's going to look something like this. Your components of the manure are along the left-hand side. They'll show analysis as received, so that's on a wet basis as it came to them. And then they'll show some different calculations, pounds per acre inch if you're applying a liquid, pounds per 1,000 gallon. If it's a solid manure, pounds per ton of each part of the manure. And when you take that information, particularly the first year availability, when we're talking about nitrogen in particular, we want to know what that nutrient value is worth when we put it on for that first crop year. So that data then we can take and plug into any number of tools that can be found online for calculating manure value. Nebraska has a manure value calculator. I've got the URL for it here. And again, I don't want to spend time going through how to enter everything and get your output and get a value in there, but I would say that if this is something you're interested in using and you need help, certainly reach out to myself or other members of our animal manure management team, and we would be happy to help you use that. So we calculate a value based on how much of each nutrient is in there and what the current market price is for the different crop nutrients. And if we think about kind of a typical or standard, and I hate to say a standard nutrient analysis because I don't want people to use book values for nutrient management, right? We want you to sample from your operation. But if we just kind of look at some kind of average or typical manure analyses from a swine slurry finisher operation, and we look at how much nitrogen is in there and how much nitrogen is needed for a 200 pound per bushel or 200 bushel per acre corn crop, we could feel fairly confident that we could meet the nitrogen needs of about 100 acres of corn crop from the manure that's produced by 1,000 finisher pigs. And so in Nebraska and other parts of the Midwest, it's fairly common to see 2,400 head finisher units. So if we think about one 2,400 head finisher unit on an annual basis, we could estimate that we could meet the nitrogen needs of 240 acres of corn with the manure that's produced by those animals. Assuming then when we take that 2,400 head finisher system with a deep pit storage and we assume a 125 per acre cost of fertilizer for corn production, and that varies day to day, month to month. But if we take that value and look at the nutrients that are in our manure, we could estimate a value to that manure of around $30,000 per year. So again, completely just looking at nutrients, not thinking about the transportation, the hauling, the application costs, because those, everything that goes into that brings that cost down a bit, or that value down a bit. But purely looking at the nutrients, there's significant value in stored swine slurry manure, largely due to the fact that it's a covered system, so we don't have rainwater causing dilution. We don't have as much nitrogen losses as we would from an open system that's exposed to the wind and the environment. So swine slurry operations are particularly good at retaining nutrients and having a fairly balanced nutrient profile compared to some other types of manure. So I just want to touch on some of the basic concepts that we like to talk about for capturing the value of nutrients in manure. So we think mainly nitrogen, phosphorus, and potassium. As far as phosphorus, if we don't need phosphorus on a field, but we apply manure that has phosphorus in it, that's okay. You can build phosphorus, but you're not getting value from the phosphorus that you're applying. So you're putting it on, but you're not getting value because the crop doesn't need it. It has what it needs there. So we want to target fields that are low in phosphorus or that have higher phosphorus requirements. Corn silage, where we take off the majority of the plant and therefore we harvest the majority of the phosphorus that was used by that corn plant. With potash, again, we may or may not need that on a field. If we can apply manure to a field where that potash is needed, then we can assign some value to the potash in that manure. Otherwise, it's there. It factors into the overall value of the manure as it sits in the storage, but it doesn't factor into the value of it as a fertilizer on that field. And then nitrogen, we're usually applying on a nitrogen basis. So what we want to do is conserve ammonium nitrogen, injection, incorporation, those types of practices with our application. And of course, apply ahead of non-legume crops so that the nitrogen is needed by the crop. Thinking about then kind of the more abstract benefits that we see from manure, so soil health value. Typically, we think about the organic matter that's in the manure and the microbes. There's microbes in the soil, but there's also microbes in the manure. And when manure is added, that organic matter is a food source for the microbes that are there in that soil environment. When a food source is introduced, the soil microbes are happy, there's food source for them. They start consuming and breaking down that organic matter, and as they do, they're producing a byproduct of polysaccharides, which is a sticky substance that causes the soil particles to stick together. So it causes soil aggregates, and some of our tiny soil particles get together and form bigger aggregates and larger ones. And when those larger soil aggregates are forming, then our soil is less prone to runoff and erosion, and we typically will get better infiltration rates. So definitely benefits. Those are things we think about with our cropland, but we may not necessarily be able to put a real strict value on. And so if we want to capture the soil health value of manure, we want to look for finer textured soils, low organic matter, issues like crusting or ponding or runoff and erosion, and some of the aspects of soil structure that we've talked about a little earlier. So I'll just kind of close with kind of talking about organic fertilizer versus inorganic fertilizer. They're both they're both going to provide nutrients. The nutrients they may be inorganic nitrogen or organic nitrogen in the manure. So they may be readily available or not available for a while. But the nutrients are, they're both delivering nutrients that plants need. One major difference is the perceived convenience of ordering fertilizer versus purchasing manure and having to get an analysis and having to make decisions about how to apply that. There's some differences in cost. Definitely perceptions about the benefits and barriers between organic fertilizer and inorganic fertilizer exist. But one thing I would say is that the plants don't know the difference. Whether inorganic nitrogen comes from an organic fertilizer source or an inorganic fertilizer source, the plant doesn't know, but the soil absolutely does know. And the soil is what's going to probably offer the greatest return on investment beyond your nutrients. So building that soil structure and quality is what we can look at beyond the value that we just get purely from the nutrients. So I'm going to close with that. I kind of add that, if you recognize the value in improving soil structure and function, which can ultimately impact the quality of your cropland, the resilience of your land, and the long-term value of it, then I think you can begin to think beyond the nutrients that are in manure, appreciate some of the benefits that we often overlook, and recognize that those are long-term changes, but they certainly have value in the system. So with that, I'm going to turn it over to Andy, and I think we'll do questions at the end of his presentation. So
yeah, thank you for that, Amy, and I'll go ahead and throw it right over to you, Andy.
Okay. Okay, hopefully you can see the slideshow there. For the sake of time, I'm going to be very brief. I'm going to skip over several slides to make sure that I try to leave a couple minutes for some questions. Probably just got 3 or 4 slides that I think are really important to touch on, and we'll try to leave some time for questions. Real brief overview on Nutrient Advisors. We provide services to livestock producers and crop producers across the Midwest. We do environmental compliance, facility permitting. Our key expertise is on the agronomic side, where we tie together compliance information together with agronomy and focus on bringing the most value that we can back to an operation that is producing livestock nutrients, or to their crop producing neighbors that have the opportunity to utilize those nutrients. Maximizing those resources that are often viewed as a waste or a byproduct of livestock is really key, and obviously we're talking about manure management today. One common misnomer in the public perspective is that a livestock producer wants to do things that are bad for the environment. Couldn't be further from the truth, and as a matter of fact, as we think about nutrient management, the reality is that everybody wants the same thing. Agronomics, economics, and environmental regulation truly all want the same thing. And if we can put the right product for our nutrient management, we put the right product in the right place, at the right rate, and at the right time. When we do that, we're not overapplying nutrients, we're not wasting money, we're maximizing yields. And what we can achieve is the cleanest water, the highest yields, and the most profit. Nutrients have tremendous value. That's the subject matter today. And a farmer has no incentive to overapply nutrients or underapply nutrients. And so a key part of what we do as a company is to make sure that we hit the sweet spot and we dial in exactly what rate is right to the right field, to the right area of the field. This slide on manure management has a picture of a combine and a grain cart, because ultimately, if we're not achieving maximum yield and maximum profit for all parties involved, both the livestock producer and the crop producer, then we're leaving something on the table. We're either leaving bushels on the table or we're leaving dollars on the table, but not utilizing all of our nutrients on the right acre. And so that's our focus, and to maximize profit in that way. I'm going to skip a few here. Will, you'd asked me to talk specifically about some logistics, and I think we can talk about a lot of things, but I just put together a few pictures to help the viewers understand exactly how things are done, especially in deep pit manure pumping. So this first slide is just a medley of pictures, the different ways that deep pits are agitated and pumped out. You can see a picture of a vacuum tank, and that is when that tank has an attachment that literally uses vacuum pressure to suck the manure out of the deep pit. The slide to the right is a drag hose injection system where they are agitating the pit and pumping that out through a hose system. And then the bottom slide is actually a beef confinement, but you can do the same thing in hog confinement, is that you're using a pump and a standpipe and loading either a tanker injector or a semi. And then that moves into transport. We really only have 3 ways to get liquid manure, remembering that we're at 95% moisture typically on deep pit hog slurry. And the semi is a way, if we're traveling a significant distance, you can haul the product to the field with a tractor and wagon, or what is really becoming popular is pumping that through a hose that is laid through culverts across other fields to the field that we want to apply on. That leads us to the application. Really 2 ways to inject slurry would be to pull the tanker pulled by a tractor through the field and inject that product, subsurface injection, or drag hose injection, which is really the same type of opener, but we are injecting and pulling that hose through the field as our supply line. A couple of different types of injectors. On the left, that is what's commonly known as VTI, or vertical tillage injection. It's a relatively shallow injection system, but an operator can go at much higher speeds. They can get more done with less horsepower. It's really become a favorite of custom applicators for those reasons. The injector to the right is more of a knife type of applicator. We're able to inject deeper, which in some instances is safer for the crop, but it does take horsepower. It takes a lot of power to pull those knives through the field, and also has quite a few more wear parts and more maintenance with those systems. So one last slide that I wanted to go over is this is one of our manure value calculators. What you're looking at in the top table here is the same manure sample on two different lines, but I wanted to show the difference in value of if we are injecting that manure versus surface application. And so if you look at the upper right-hand corner, you can see a value per 1,000 gallons that we lose about $17 per 1,000 of value if we are surface applying. We lose all of our ammonia nitrogen. You look down on the bottom table at a 4,000 gallon rate, with injecting, we're getting over 200 pounds of nitrogen available to that crop. If we surface apply at the exact same rate with the exact same product, we only have about 40 pounds of nitrogen available. So you can see how important it is to inject and manage those nutrients at the highest level. Again, our focus is to not leave any dollars on the table and to maximize the value of the resources, whether it's the livestock operator or their crop producing neighbors that have the opportunity to use those nutrients. So with that, that's the end of my slides, and I'd open it up for questions.
Well, thank you, Andy, and thank you, Amy. Certainly appreciate your you guys coming on and sharing your knowledge. That's a question we get a lot from producers, either current producers or those that are looking at these opportunities, is how to value that nutrient in their row crop enterprise. And I think Amy and Andy as well certainly appreciate the numbers you shared on those slides to give us something to look at. As a reminder, we probably got about 5 minutes here if anyone wants to submit any questions for this panel. But I guess I'd just start with you, Andy. As you develop nutrient management plans for your clients, what are 2 or 3 key takeaways that people need to keep in mind as they're working with you to put together these plans?
Sure. Probably one of the main factors that Amy mentioned in her presentation is their location and their soil types. The difference between a hog producer with deep pit slurry that has generally sandy farms, light texture, the inability to hold a lot of nutrients, that really changes how we manage those nutrients completely differently than if that operator has clay soils, heavy soils that can hold those nutrients. Along with that is how much of the land in their plan is their own, and then how will they work with their neighbors? How do they communicate with their neighbors what it is that they have? And that's really where we come in as a third-party liaison to represent the value both to the producer of the nutrients as well as the end user of the nutrients. But those key foundational things really determine how we proceed with a quality plan.
Sure. And as we talk about valuing manure and valuing nutrient, we can come up with a number on a spreadsheet, but sometimes it's hard to convey that true value to the end user. Or when we're looking at financing for these projects, it's hard to convey that value and that added value to your banker. For say, I open it to either one of you if you have any advice on just how you can help convey that true value.
I usually, when I talk to producers about that, I talk about it more along the aspect of marketing the manure. Then you're going to have to go beyond just telling them what they get nutrient wise, showing them the quality of your soil, showing them the change in your crop productivity when you added manure to a system. I think those are really important aspects, and part of what we do in Extension is trying to demonstrate that through field research and on-farm research. So to me, it comes down to the marketing and showing the benefits.
I do have one question from the audience that we'll probably close with as we're getting on to our 2 or 3 o'clock hour. And that is, they're asking if you guys could share some of what you are seeing in terms of emerging precision manure application technologies that are benefiting producers. So some of those emerging application technologies. Andy?
Sure. There's some exciting technology coming on board. We've started to write quite a few prescriptions and doing variable rate applications for operators, especially if they have variable soils and variable nutrients or nutrition in their soils. One of the other new technologies that is on the horizon is John Deere has developed technology where they are taking real-time lab analysis of the manure as it goes through the machine. So instead of dialing in a gallon per acre rate, it would actually set the applicator to apply a certain amount of nitrogen or a certain amount of phosphorus. And with that dialed in, it would vary the gallons per acre to make sure that we're consistently applying the same rate of nutrients.
Any thoughts, Amy?
No, I don't think I have anything specific to add. I'm going to drop a URL in the chat box of a webinar that was hosted by the Livestock and Poultry Environmental Learning Community a couple months ago that was focused on precision application of manure. And so I think the speakers and the topics that were covered in that might be of interest to some folks.
Great. Well, again, certainly appreciate you guys joining us here today. I think we could have gone a lot longer on this topic, but appreciate your preparation and your presentations. It's a question, or these are questions that we deal with all the time here at what we do at AFAN. So appreciate you sharing some of that on the Nebraska Pork Expo here today. So thanks